Right, welcome to this video on solving vanilla flavored trig equations. Let's dive straight in. Right, so let's take an example. We're just trying to solve this equation. The first thing that we do is we isolate the trig ratio. In other words, we get the trig ratio on its own. So we're going to subtract 4 from both sides and divide both sides by 2. That gives us sine theta equals -1/2. The next thing we do is we find a key angle. And this is a really important idea, that we don't put the negative into the calculator. We just undo, we find the inverse of the trig function on the positive value of the ratio. I've actually written a +1/2 there just to emphasize that. We get 30 degrees. In this case, 30 degrees is not a solution, but it's the angle that will enable us to find the solutions. The next thing we do is we establish in which two quadrants our solutions will lie using the cast diagram. All right? We want sine to be negative, and that happens in quadrants 3 and 4. Next up, we use our key angle and the horizontal axis to generate two standard solutions in the correct quadrants. So we want to be in quadrant 3 and quadrant 4. So we take the horizontal axis 180 plus the key to get into quadrant 3, and the horizontal axis 360 minus the key to get into quadrant 4. So we get those two solutions. Those are what I like to call the standard solutions. Next up, to each of those standard solutions, we add 360k to get a general solution. And that's the general solution for this equation, because to any of those solutions, either of those standard solutions, we can add 360 as often as we like, or subtract 360 as often as we like. So what we say is we plus 360k, we must say k is an integer. All right, that's really, really important. Next up, we solve for theta if necessary. So there's no solving to be done here. And then finally, we write down the specific solutions in the given domain. So here we're looking for answers from 0 to 360, and they're obviously just 210 and 330. It wasn't necessary to write the general solution in this case, but very often we need to use the general solution, as will be shown by this next example. Okay, over here we've got something a bit more complicated in the sense that there's something going on inside those brackets, right? And that 2 theta, we will know from our graph work, is actually going to cause the graph to sort of squash horizontally. We're going to get more solutions in a given domain than usual. Remember, we normally expect 2 solutions per rotation. Here we're looking for answers from -180 to 180, so that's 1 rotation. Normally we would get 2 solutions. That tan 2 theta is actually going to give us twice as many. We're going to get 4. Let's look at how to find them. As last time, first thing we do, isolate the trig ratio. Right, so we've subtracted 1 from both sides, divided by 5, and we've got tan of something equals 2. For me, that's now what I described as a vanilla flavored trig equation. Next up, we find the key angle. Remember that we wouldn't undo the tan of a negative if there was one. In this case, there's not, but just to emphasize it, I've put the plus there to remind you. Now we've got our key angle. In this case, the key angle is actually a solution, as we'll see. Next up, we establish in which quadrants we want our answers to be. Well, tan is positive in quadrants 1 and 3. Right? Next up, we're going to use the horizontal axis to generate our 2 standard solutions between 0 and 360. Right, so we want to be in quadrant 1, that is just 0 plus our key, or just the key, or in quadrant 3, 180 plus the key. So those are our 2 answers. Now, next up, we normally add 360k to each of the standard solutions to get a general solution. But with tan, the solutions will always be 180 degrees apart. They'll either be in quadrant 1 and 3, as they are here, or 2 and 4 if tan was negative. Right, so what we're going to do is we're just going to take one of those, all right, just one of our standard solutions, and add 180k. It just saves us a little bit of time. We don't need to have both. All right, next up, we are now, and this one says solve for theta if necessary. Now there is some solving to do for theta, because that was 2 theta plus 10. So we're going to subtract 10 from both sides, divide by 2, and notice that we now get plus 90k. Right, and note that 90k rather than the 180k is what's going to give us more solutions. The final thing we're going to do is write down the specific solutions in the given domain. So we want to be from -180 to 180. If k is 0, all right, we get 76.7 degrees. We can add 90 once. We can't add 90 a second time without going outside. but we can subtract 90 twice and we get those four answers. I hope this was useful. I hope you have a great day.